2.3 is on decision making and data. And the decision making method that's given in the book or what it says about the decision making method is that it should clearly define the problem and any influential variables. So, if I go in to the doctor and I have high blood pressure, then maybe there's some other medication that I'm taking that's making this happen. Maybe it's because I'm drinking too much caffeine and having too much stress at work. So, you have to clearly define the problem and any kind of influential variables that go along with that problem. You have to decide upon objectives. And decision criteria for choosing a solution. You have to create alternate solutions. What works for me may not work for everybody in general, or even there may be some exceptions. So we have to think about alternate solutions. We have to compare alternatives using the criteria established in the second step. Compare alternatives using the criteria established in the second step. Implement the chosen alternative. And check the results to make sure the desired results are achieved. The most important step of the decision-making method is to define the problem. Okay, because if you can't figure out the problem, then from that point on, everything else is shot. So diagnosing the problem is definitely the most important, and then figuring out any influential variables, of course, would also be very important. That's in that first step. Alright, and that finishes 2.3. 3. 2.4 is on something a little bit more interesting, I guess, in my opinion, collecting the data. So think about all the ways that data has been collected from you. Whether you've ever filled out a small survey online for money, have two ways to obtain data, by observation or by a controlled experiment. Okay, so two ways to obtain data. So observation or a controlled experiment. Alright, a response variable measures the outcome of interest in a study. An explanatory variable causes or explains changes in a response variable. All right, your book goes through an example on tomatoes. Anybody here like tomatoes? I love them. Can't get enough of them. All right. And it says, suppose a new species of tomato has been genetically engineered to increase yields. The question is there a relationship between the use of the new species and yield? And your book says the solution is, in this experimental design, the plots of tomatoes will be divided into two groups, one that contains the new species and another that contains the unaltered variety. The plots containing the genetically engineered variety will be called the treatment group. All right, think about it. If you've done something to that group would be called a treatment group. And the plots containing the standard variety, those would be called the control group. All right, so again, the treatment group, that would be the group that something has been done to. And then the control group, that's going to be the group that nothing has been done to. There's been no, it's not a new genetically engineered variety. If the experiment is properly performed, any changes in the response variable, or the yield, can be attributed to the explanatory variable, or the genetic engineering, and not to other variables that are controlled. The untangling of variables at the data gathering stage makes the analysis of the data much easier. There is no better way to establish a causal relationship. Variables like rainfall, amount of sunshine, or type of soil can affect the yield of tomatoes. These variables must be controlled in the experiment so the differences in yields between plots can be attributed just to the genetically engineered species. One possible method for controlling these variables is to create small plots in the same field. Think about it. If you create plots in the same field, then they're probably going to get the same amount of sunshine, the same amount of rain, so you won't have to worry about controlling those variables. Several plots of each tomato are planted. Each plot contains only one type of tomato. Rainfall is measured and supplemented with irrigation to assure that each plot has the same amount of water. By controlling these variables in this manner, we can say that any differences noted in the yield, or the response variable, between the genetically engineered variety, remember that was the treatment group, and the unaltered variety, or the control group, are due to genetic improvements. And that would be our explanatory variable. This is all in the book. I'm just, that's kind of your book has a few examples to kind of help explain how the response variable and explanatory variable, the difference in the two, how they're used, the treatment group, the control group, how those are used. So it may be worth just reading through that briefly, or reading through the PowerPoints to see those examples. Because there's a lot of examples in the book that we're not going to go over, especially these first couple of sections. We're just trying to get through all of these terms, okay? And that'll kind of help set up the rest of the book. And so that finishes 2.4.